Okay, if we want to solve an equation with a root in it, the very first thing you want to do is get the root on one side by itself. Once you get that square root by itself, then you can square both sides to get rid of the root. We're going to do two separate problems. But the other thing I want you to remember right in the beginning is if your original equation has a variable underneath an even root, checking your answer is not optional. This is the second time this has happened. If the variable is in the denominator of the original equation or a variable is under an even root, checking your answer is not optional. So right off the bat, I just am going to put up here this check mark to say when we're all done, we're checking our answer. Using that strategy, I'm going to get the square root of w plus 11 by itself. So I want to move over the 12 by subtracting 12 from both sides. And now my root is alone. Once the root is by itself, I'm going to square both sides because that gets rid of the root. So if I square both sides, the w plus 11 is now over here by itself. Negative 5 multiplied by negative 5 is positive 25. Finish getting w by itself, so I'm going to subtract 11, and I find that w is equal to 14. I need to check my answer, so I'm going to go back to my original equation, and I'm going to replace the w with 14. So let's grab that 14, drag it down here. If I put in 14, 14 plus 11 is 25. So I'm bringing down my plus 12 and my 7, and then that becomes the square root of 25. When I find the square root of 25, that's 5. So I now have 5 plus 12 is equal to 7. And 5 plus 12 is 17. And 17 does not equal 7. So since this right here is not true, it means we need to throw this out. It's not actually a solution. So I'm going to come up here and I'm going to cross out this w equals 14 because it is not an answer. And my answer is a no solution. There are no real solutions to this equation. All right, so let's do one more. Notice right off the bat, I'm putting a spot to check it because when that variable is underneath an even root in the original equation, checking is not optional. My strategy is to get the square root by itself, and to get the square root of v minus 13 by itself, I'm going to need to add 2 to both sides. Now that my square root is by itself, I can square both sides to get rid of the root. Squared it. Now that frees up that v minus 13. And 5 times 5 is equal to 25. Finish getting the v by itself by adding 13. And I end up with v equals 38. Checking this answer, I grab my original equation. And then I'm going to replace the v with 38 and see if it works out. So let's put 38 right there. 38 minus 13 is 25. So the minus 2 comes down, the equals 3 comes down, and this becomes the square root of 25, which is 5. And 5 minus 2 is 3, and 3 does equal 3. Since substituting 38 leads to a true statement, I know that this is actually the answer. So my final answer is 38.